Okay, so that's searching, that's inserting. Now, what do we need to do before we could delete an item? So going back to our example, what if we needed to delete Coco? Well, first thing we need to do is we need to find it. Okay, so let's look at some skeleton code here. So if we said we find the search key with a search and we could assign it to n, well then that'd be easy. If n is null, we have a tree exception. Otherwise, we delete n. There we go. Great, that was easy. Well, what about delete node though? Okay, so well, in delete node, we got to write that. We can't just leave that hanging. We have three scenarios. One, n is a leaf. Okay. Two, n has one child, and three, n has one child. Let's go back to scenario one. N is a leaf. Well, this is easy. Just delete it and set its parent's pointer to null. We're done. So an example of that would be Coco here. We found it. It's a leaf. Set the child pointer here null, and we're good. Okay, what if it has a child? What if we're trying to delete Sugar, for example? Then it has one child. What do? So we replace n with its child. So Sugar is n here. We just take Rice and we move it up. It preserved the binary search tree qualities, the characteristics. And we need to be careful. At the end of every operation, we have to have preserved the binary search tree characteristics. Okay, great. But what if it has two children and we're trying to remove it? This one's a little bit more challenging. In fact, let's not do it. Let's just find something else. For example, if we were going to remove Flower here, then it has two children. We can't just easily replace it. Wheat here with one child, going back to scenario two, we could just replace Sugar with Wheat here, and Rice would fall along and would preserve it. But we can't do that here with Flower if we want to delete Flower. So what we're going to do is find a different node that is easier to delete. Okay, well, what would be an easier to delete node? It can't just be any node. It has to preserve the definition of the binary search tree. So we'll pick the node for an item just greater than the current node. And the way we do that is it's the in-order successor. So it's the leftmost node on the right subtree. So if we're trying to delete Flower, what we'll do is instead we'll find this node, we'll move this node up into Flower, and then we'll copy Flower here, oats over Flower, and then we'll delete this node, okay? Because this node's easy to delete. It's a leaf, no problem. Just delete it. Okay, so let's back up. What if we were actually trying to delete Pasta now? If we're trying to delete Pasta, it has two children. It's the more challenging scenario. So then we find the in-order successor, which is the leftmost node of the right subtree. Okay, right subtree, leftmost node. Leftmost, Rice. Rice is going to be the next node that is just greater than Pasta. There's no nodes between Pasta and Rice. And so if we took Rice and we copied it over Pasta and then we deleted Rice, then we would have effectively deleted Pasta, which is a lot easier. So let's go with easier. Yes, you could choose the in-order predecessor, but you just need to stick with one. Either one would work. Okay. So let's look at some skeleton code. So if node pointer is a leaf, this is for delete node now. Great. Remove from the tree. Otherwise, if it has one child, well then we need to determine which child it is. Is it the left child or is it the right child? And whichever one it is, just move it up. And any subtrees that it has, great, bring them along. But we just remove that node. But if it has two children, then we need to find the in-order successor. We're going to call that I, to node pointer, which is the leftmost node of the right subtree. And then we're going to take I's key and replace it, replacing node pointer's key, and then we remove I. Much easier than trying to figure out everything and make the tree work. Okay, so the strategy is when you try and delete something with two children, you don't delete it. You actually find something easier to delete and move it in. Okay, that's what we have for today.